Hey guys, Faxi Nadu here, and I'm going to be showing you today using Synth Edit a little bit about LFOs, how they're built, kind of not just how the basic core of the LFO is built, but also how to kind of give it the controls that you want. And we're going to be using, again, Synth Edit, like I said, to show this. So I have a patch that I'm working on, and if we go inside, in various sections I have LFOs that I'm using. And this is an LFO that I have. This is going to be our end result. An LFO that has basically all the functions that you could think that are needed on an LFO, which is a waveform chooser, the ability to choose whether you want to have free-flowing speed control, or let's look at the panel better. Have free-flowing speed control, or sync to BPM, and LFO depth, and the LFO can also be gated, retriggered, so-called. So what we're going to do is let's take a look at one of Synth Edit's pre-built LFOs, which is what I've used to make my LFO. And it's really nice that you already have inside here this one, which is a tempo synced LFO. And this is what I wanted for my patch. I wanted the option to have an LFO that has the ability to tempo sync. So I was kind of happy, yay, there's a tempo sync LFO module already available. But then when you load it, you notice that while it is synced to the tempo, that's the only option it has. You can't even choose which waveform it's on. You can't choose the depth. You can't really modulate the depth, and the sync is always on. And plus, it only goes down to 1/16. What if you want 1/32, 1/64? Just to go a little lower. So I kind of decided to take this LFO and kind of play around with it until I get the LFO that I want. And let's open the structures of both of them for a minute. So this would be my LFO, the new version of the LFO, and this would be the tempo sync LFO and what we want to work on. So as you notice, if you open this LFO, they already have everything going that the end result brings about, this thing, which is a tempo synced LFO with the ability to choose divisions. Now we want to add our other things. Now if you look at the way that the patch goes, you'll notice that the core of the LFO is actually just an oscillator. I guess most of you know this. An LFO is just an oscillator receiving pitch information, frequency information at a very low frequency, and which turns it into a control signal. It's as simple as that. So what they have done to get the BPM sync, you have a BPM clock module which listens to your DAW's tempo and outputs whatever tempo it is. And then they have the mathematical divisions that together, divided with the tempo, bring about a tempo sync. It's as simple as that. So we're not going to rebuild this entire tempo sync thing, but we're going to add to it the functions that we feel that are missing. So the first most important and trivial function would kind of be to be able to select the waveform. Now if you look at this oscillator, there's already a waveform selector pin out. So all we need to do is have a way to choose which of these waveforms. We don't need to program the whole thing. We just need a choice. So over here it's in controls in Synth Edit, and we're just going to use a list entry. And as we connect it to the waveform, like I said, internally it already has all the waveforms aligned inside waiting for a choice. So the list entry, you see it changed automatically to the various wave shapes of the oscillator. So we can already rename this. We can already call this waveform. And if we look at the panel, along with the division, now we already have our waveform selector. So that is already kind of cool. Now the second thing I wanted to do is, if you look at my patch, there's also the ability to choose whether you want your LFO to be synced, whether you want the speed, the frequency to go through this whole algorithm and derive the frequency, or do you want to choose your frequency with a knob, you know, just to have a speed slider or knob? I don't like these knobs. Let's get the simple knob. Let's get a knob in there, or a slider. Let's keep it as a slider, doesn't matter. So you want to have the choice of controlling, you know, just with hertz, have a free running LFO that isn't tempo synced. So you want this slider or this whole division. So let's delete this connection. You don't want it to go directly in there. You want to be able to choose between the two. So if you look over here, it's as basic as I've taken a switch, many to one, and as you notice, again, it is kind of like it has the same green input, which is a choice input, and it has spare input, means that I can, the minute I connect one thing to it, it'll all automatically open up a new input. This is something with the synth edit syntax. So the switch can be as large or as small as you need it. Right here we only need a 2-option switch. We need the sync and the unsynced signal. So if you look right here, I have a divider going. Now why do I have that? If you look, this slider, the range for the slider is from 0 to 10. And the way synth edit is set up, it's 0 to 10. The units that it's using, it's calling them volts. Now if you go into the oscillator frequency scale, you look right here, 1 volt per kilohertz. So that means that if you send it from here a value of 1 volt, it actually means in the musical terms that we're used to, in hertz and kilohertz, it would mean 1 kilohertz. So that would be a really fast LFO. So what we kind of want to do, and again, if we get to 10, if we send it 10 over here, then it'll multiply it by 10, right? So it'll be 100 kilohertz. So that's way too fast. We don't want it that fast. So it'll be 10 kilohertz. So we don't want it like that. So what I have here is a divider, and we can just copy paste my divider into here. And the divider has a value of 100. What this means is if I input the signal into here and then go into the divider, so that 10 divided, you know, if you look over here, let's bring in not a frequency, a voltmeter. This will show me what is coming out. Okay, so if we go over here, I don't need MIDI. So that value is being scaled from 9 to 0.090. So let's take a calculator for a second. And remember that 1 volt is 1000 hertz. So let's multiply this by 0.09 times 1000. What we get is 90 hertz. So, and that's on 9. So our LFO, after we go through the divider, it's, you know, it's limited, it's scaled to 0.01 hertz up to 100 hertz basically. So it's a low frequency oscillator that is going just a little bit into audio rate. Now we could have obviously band limited it down even more, but 100 hertz is cool. Let's see, you know, I decided to have the ability for the LFO to go a little bit into audio rate. You can have it obviously go more into audio rate if you want to, but I'm just showing you the technique to scale the speed of the LFO. So the signal is going into this divider and then it's going into the switch. So let's go back to ours. So divider, and I don't have the second input here because the value for the second input I've already put it on the module itself. So it's input divided by 100, and then the output goes into the switch. And now we need to rename, let's rename our choices on the switch. Let's call one of them sync, and let's call one of them, what you want to call it. Let's call it hertz or free, whatever you want to call it. So now input 1 is choice of sync. Input 2 is choice of hertz, and it is correctly scaled the way we wanted. Now all we need to do, let's move this aside, up. All we need to do is, like the waveform, right? We need to bring in another choice. So it's in the list entry, there we go. Ta-da! So sync or hertz. So either one of them. And now if we look on the panel, we have waveform, we have the choice, and let's not call it list entry, let's call it what do you want to call it? Let's call it sync slash, that's the chooser for this, and the division. So when it's on sync, this is your speed, and then let's move the slider, let's call it speed. So when it's on sync, this would be your LFO speed, and when it's on hertz, this would be your LFO speed. So that's really cool. We already have that option going as well. And so yeah, we have made both the speed knob and the choice. So we've kind of already gotten the LFO a bunch of more things. Let's look right now at the division itself. As you notice, it is going from 4 bars, 2 bars, 1 bar, 1/2 bar, 1 bar. 2 bars, yeah, full bar, half bar, 4th, 1/8, 1/12, and 1/16. So what if we want to have, like we said, 1/32 and 1/64? All we need to do is we take the values, 16. You see that 4 bars is on 16. And then let's look what happens. Half the time, 2 bars, the value coming out is 8. 1 bar, the value coming out is 4. And you notice it's always a division of 2. Again, 2, 2, 2. The only one that isn't 2 is this 1/12 thing. But we don't need that because we want 1/32 and 1/64. So it's as easy as, again, a division of 2. So let's take the module that allows us to input these values, and it is called a fixed value. And let's take 2 of these. So let's get 1/32 and 1/64. So, and let's connect them. As you notice, every time I'm connecting, remember I said it's opening another extra input that I can use. Let's go into the, and then what number do we need, right? It's really easy. All we need is a calculator. Let's go into calc again. Let's put in this number, and it's 0.0625. Let's divide it by 2. Then we get this. Copy. Put this. I'm going to label, this is the actual value, but I'm going to do it like they did. I'm going to label it with the number as well. And there you go. And we can also name the module 1/132. And let's name the choice. Well, let's do that in the end. Let's do the 1/64 as well. So obviously it's the same thing. Now we're taking this value, the 0.03125, and again dividing by half. And we get this value. Copy. Go in here. Paste. And this would be 1/64. Now let's go on our divisions, because if we don't do this, I want to show you what I want to do is I don't want it to say spare input. It's not saying it at all here. Why not? I want it to say divisions. I want it to say 1/32 and 1/64. Let's see if it put it on here. Yeah, there we go. So now we have also that. We've expanded the LFO even more. You can actually, if we do 32, we can have an 8 bar LFO. You want to do an 8 bar LFO? Let's do the opposite. Nah, well, we're going to have to move them. Let's just say this. If you wanted 8 bars, all you had to do, remember we did division? So yeah, all we have to do is multiply. So we would have this be 32 and have it here. easy as that. Let's just keep it this way for now. So we've added that as well. So we have more divisions. Now all we have left is if we connect this right now. Okay. Oh, okay. We didn't connect this. Yeah, we need this to the pitch. So if we connected it right now and connected this LFO to something, it would always be on. The LFO would always play because it would have a fixed volume. It'll probably, as I know Synth Edit, it will be fixed on 1. It'll actually be playing on full volume. So you'd have no way to decide on the depth of the LFO and whether to turn it on or off. It'll always be on and it'll always be on full depth. So what we need to do is as easy as controlling the volume of the LFO. If you look right here, all it is a VCA. VCA, that's it, an amp. So let's take the amp. And instead of going straight outside, the LFO is going to go into the signal input of the amp. And we need a slider, another slider, volume. And now the slider is controlling the volume of the VCA. And the VCA is an internal Synth Edit module. It is already scaled, you know, to the 10 volt kind of 10 volt would be maximum and then 0 would be minimum, and you have different values for the depth. And let's call it depth. So, depth. And if you want to have a look, the scope here isn't that great, but we can take a tiny peek. As we take the depth on or off, the volume of the VCA on or off, that's the depth of the LFO. And again, we can test it out a little bit. We can look at our speed. Let's see. Now it's on hertz, so speed should be working. And if I put it on sync, obviously there's no BPM information coming in now, so it's not syncing to anything. I don't know what, it's holding some base value, but whatever that value is, I guess this should be, yeah, this should be moving it. And then this should be doing nothing. Great. And if we move to hertz, this should be moving it. And this should be doing absolutely nothing. Okay, so yeah, everything works. And now we can, this will be the output of our LFO. And now if we connect this module to anything, it'll do all these options that, you know, that we have built. But let's do one more thing. First, let's look at the panel for a second. So we have depth and speed. And the last thing I want to do is actually to have the ability to gate and re-trigger the LFO. So what that actually means, it's exactly like the same as ask sync and ask re-trigger. It means that the LFO phase will be restarted from the initial phase every time that you hit a new key on your MIDI keyboard or on a sequence that you're sending it. So it's kind of like it'll have the same attack and actually progress in the same kind of way every time. And it's as easy as that. All you need to do, this sync input, okay, it provides, it also works for oscillator sync. It lets you restart the LFO. So while also good for doing ask sync functions, it's also great for just re-triggering it using gate. Because the gate signal, when it comes in, it'll give this input just the value of 1. And this input, whenever it gets anything that is higher than 0, it knows to perform the sync operation to re-trigger, to restart the oscillator waveform. So it's as easy as taking this and connecting it outside to the I/O mod, which is actually, you know, whatever is coming into the module, and then connect the input of the module itself. Connect this this input, let's call it sync. Yeah, it is calling it sync automatically. Connect this sync into the gate coming in from your patch, from the outside of your patch, which is over here. The MIDI in, the gate. So we'd have to go into wherever it's placed in the patch and connect that, and that'll sync the LFO. But again, if we do that, it'll always be gated. The LFO will just be a gated re-triggered LFO. What if we want the option? What if we want to be, oops, where is our LFO? That's Yeah, this is our LFO. What if we want the option? You know, we don't want it to always be on sync. We want to be able to turn it off and on. So all we need is another switch many to one. Switch many to one, and we'll get a list entry in there already. And this will be our choice. Obviously now there's no choices, so it's not doing anything. And we want to connect the incoming sync signal to one side. Let's connect it to the, let's do it the other way. I'll show you why. So, okay, what I mentioned before is over here on the sync. You remember when I said when the sync input receives a 1, it knows how to retrigger? And as long as it isn't on 1 or anything that is other than 0, it just continues on and doesn't perform the retrigger operation. So all we need is a fixed value of 0, right? If we connect this here, and let's give it, the value will be 0. This outputs 0. So if we connect this right here to the sync and keep it on this first option, let's call it off. So while it is connected here and chosen, there's no sync going on. The oscillator is running. You're not retriggering on every single MIDI note because the sync value is 0. It's, you know, telling it don't retrigger. But if we connect it outside, right? We're getting the gate signal from outside into this input. Let's call this input, let's give it a name. Let's call it gate. And let's call it gate over here. And now it's connected. Now it's working. The output of the switch is connected into the sync input, and it is telling the LFO whether to be, oh, let's call it on. Okay, yeah, we called it gate here too. Let's use a different terminology that is more musical on our synth itself. So let's call it on. And then we have off and on. Let's call it gate. Look at our panel. There we go. So now the LFO can also be retriggered. So if you take a look, let's look at my XLFO. I want to make sure we did all the things that I did. Yeah, it's exactly the same. So you have the waveform chooser, you have the ability to sync to hertz. We've added more divisions, and we can add more if we want to. We've added a depth knob, we've added a scaled speed knob, and we've added the ability to retrigger the LFO. Now what you can do with this, you can take that original you know, tempo LFO that we had over here, make all these changes that I've shown you how to make, save this as a new module, and you've got yourself a full-fledged, really cool working LFO. So I hope you took some stuff from here. Even if you're not working with synth edit, the syntax may be different, but the actual functions you perform are the same. So to get a depth knob, you multiply the signal. To get a, to get the right speed, you scale the knob. To get the divisions, you use the MIDI clock and you scale and divide. To get the gate, you use the sync input of the oscillator. Oh, and here it's not connected. There we go. So, yeah, hope you kind of play around with it yourself and make some cool LFOs. Obviously, you can start thinking about even more things that you can do with LFOs. And this is just some of the stuff. See you in the next video. Have fun. Bye-bye.